All right, the next few examples are all going to use these two important results that we will not prove in this video. So we have the limit as theta goes to 0, sine of theta over theta equals 1, and the limit of as theta goes to 0 of 1 minus cosine of theta divided by theta equals 0. So let's get started with example 4, which is to prove that the limit of this reciprocal also is 1. So to do this, what I would do, so we're starting off with this limit here. Okay. Now it might be kind of silly, but you know that if we've got a fraction like 2/3, I can write 2/3 as equal to 1 divided by 3 divided by 2. Kind of silly, but that is true. We can do that. Right? Because something divided by a fraction is the same thing as that thing multiplied by the reciprocal. Right? Division by a fraction is the same thing as multiplication by that fraction's reciprocal. So 1 times 2/3 is, lo and behold, 2/3. So what we can do here is use the same sort of logic here. I can say that this limit is equal to the limit as theta goes to 0 of 1 over sine of theta over theta, which this term here, sine of theta over theta, is this first term in the theorem, this first result. So now I'm taking the limit of a quotient. I've got thing 1 on top and thing 2 on the bottom. And now we know that this limit exists, the theorem tells us, and 1 is a constant, so its limit exists. So the limit of the top and the limit of the bottom exist independently of one another, which means I can use those limit laws, which means that the limit of a quotient is the quotient of the limits. So that means I can write this as the limit as theta goes to 0 of 1 over the limit as theta goes to 0 of sine of theta over theta. Well, the limit of 1, a constant, is just 1. And then we know from the theorem above that the limit of the denominator is 1. 1 divided by 1 is 1. And that proves it.